Okay, so first of all, we are looking at doing a sample space using a table. Now, for the record, this stuff was actually in 8E of the exercises, which you haven't really done yet. Okay, so I'm going to do that. First of all, we're selecting from the word harp, and then we're selecting from the word key. So what we need to do is and your table might look different, but what we need to do is we need to set up that our first option is from harp. And we have to list all the favourable outcomes. So that's what we're going to do. So for the first one, the column on the left, harp, is our first option. Then from our second letter, it's chosen from the word key. K-E-Y. Now, if you think about it, we've got 4 options from the first, 3 options from the second. There's no replacement, so there's going to be a total of 12 outcomes, if you think about it. 4 outcomes for the first, 3 for the second. So what we're going to do then is we're going to list, and this is what we doing in AT, is basically just writing out these two-way tables. So we can list the outcomes HK, HE, HY, AK, and so on. I will do that very quickly, and then we'll go through and answer some questions. Really, this is just basic probability, but remember that we've got a total of 12 outcomes. So over here we have 12 outcomes. Now it says state the total number of outcomes. Well, we've got 12 outcomes, which is a 4x3 table. It says find the probability that the 2 letters chosen will be H then K. Well, H then K, there's only one of those 12 is favourable. So what we need is the probability of H then K. H then K is equal to how many favourable outcomes? 1 out of a possible 12. And you can leave that as such. Is the question asking us for in decimals or as a percentage? No, it's not. Contains an E or an R. Well, this time, if it contains an E or an R, we have to work out which ones are we happy with. We're happy with 1, 2, 3, 4, 5, 6. We're happy with 6 out of 12. So therefore, we have the probability of an E or an R is equal to, well, we can add all of those up if you like. We can say 1 out of 12 plus 1 out of 12. But what that is going to be, there's 6 outcomes out of 12, which we would simplify as a half or 50%. Either way, either one of those would be an acceptable answer, wouldn't it? Okay, so far so good. 2 people are selected from a group of 3 females and 2 males without replacement. Now, using a tree diagram, guess what? I believe 8F was using tree diagrams. And we've done these before. Have we not done these before in Year 8? Year 9, maybe? We have actually done them, and it's to list sample spaces. Now, what the best thing to do, can someone put their hand up and tell me probably the best reason for using a tree diagram? Can someone probably give me the best reason for using a tree diagram? What about if we're selecting more than one thing? E or R. We're happy with E or R, Matt. But you can have one that has R and E. Yeah, but it's still 6 out of 12. Okay. What about this? When we're selecting 2 people, are we doing 1 trial or 2 trials, Amisha?
We're doing 2 trials.
2 trials. So when we've got more than 1 trial, that's when a tree diagram is best to use. All right? That's what I want you to think about. We don't need to do a tree diagram every time. However, a tree diagram in this case is good to use. So that's why we're going to do it, because it actually lists all the different outcomes. So let's go ahead and do this. First of all, we've got 2 people. We can select a male or a female. Okay? Now, a male or a female, I might create myself a little bit more room. So, let's do it. We've got a male or a female. Okay, now if I select a male, we've only got 1 more male to select from, because it says here we've got 3 males and 3 females or 2 males. So what we can do is we've got a male, then we've got a female, we've got 3 females to select from, And there's our probabilities. Now, we can actually list probabilities with each of those. What about if I select a female? I select a female, I've got 2 more females to select from, and then I've got 2 males. Can you see here that this is actually conditional probability? If I've selected a male here, then the chances of getting a male are suddenly 1 out of 4. We're over here. So what we're going to do now is write down the probabilities. The probabilities of getting a male is 2 out of 5 over here. Probabilities of a female is 3 out of 5. The probability of getting a male over here, once we've selected one is 1 out of 4. And the probability of each of these, if you like, is 1 out of 4, 1 out of 4, 1 out of 4, which I guess we could say the probability of getting a female in the second one for this side of the tree is actually 3 out of 4. Notice that you notice that this and this have to equal to 1 whole. All right? Now, and also 2/5 and 3/5 have to also equal to a whole. So, let's fill this out. What's the chances of a female getting out here? Well, this is actually 1 out of 4, and this is 1 out of 4. So therefore, the chances of getting a female here is actually 2 out of 4, or a half. And over here, the same thing. 1 over 4 and 1 over 4 is equal to a half. Yes, you had a question? Go. Yes, sure. All right, so now what we've done is we've done our tree diagram. Did we need to do probabilities? No, but I think that's a good way to do it, because then for the later, it says a male on the first selection. The male on the first selection is equal to 2/5. The probability of the male on selection 1 is equal to 2/5. A male on the second selection, knowing that a female has been chosen on the first selection. This is conditional probability. If we know that we've selected a female on the first selection, we're only looking at this side of the tree. This is our sample space. So directly from that, we can say a male on the second selection, knowing that a female has been chosen. What's the probability of a male given that a female's been chosen? The probability of this is equal to 2 out of 4, which is equal to a half. Straight from the tree diagram again. Now, what about 2 males? Well, that's where we're starting to go. Well, 2 males, there's only one way we can get 2 males, and that is this thing over here. Now, we've got, let me just do something. Now, for 1 male to occur, we need to, first of all, it's the probability that we got a male and then a male. When we have 2 separate trials, we need to multiply the probabilities. Just like, for example, getting 2 heads in a row is the chances of getting 2 heads in a row is 1 out of 4, because you've got the probability of a head. The probability of a head is equal to a half, and then the probability of a head again is a half. So multiplying a half by a half is going to give you a quarter. Now the probability of a tail would also be 2 tails would be a quarter. Probability of a head then a tail is a quarter. Probability of a tail then a head is a quarter. There are your 4 ways in which you can flip 2 coins. Let's have a look at how the only way you can get a male is its individual probabilities multiplied by each other. So it's 2/5 times, what is it? 1/4, isn't it? Which is equal to 2 out of 20, which we can simplify to 1 out of 10. Now, it says here at least 1 female. Let's look at the tree. First of all, if it's 1 female, we're happy with everything here, yes? Because it's at least 1 female. We started off with a female, so we're happy. What about over here? Are we happy with all of these? Are we happy with all of these? Yes. Now, what's the entire sample space add up to? I just spat. What's the entire sample space add up to? No. Out of its probability. What's an absolute certainty? 100% or 1. So, at least one female, there's only one instance where that doesn't happen. And we've just worked that out, haven't we? Or actually, have we worked that out? Isn't it 2 males? What was the chance of 2 males? 2 males was equal to... Oh, a male then a male was 1/10. Yes. So, the probability of 1 male is equal to... What was it? Probability of 1 male was equal to... Well, we'll get to that in a second. Let's just do this probability of at least 1 female. We're going to subtract 2 males from 1, which is 2/5 times 1/4, which is, that was 1/10, so that is equal to 1 minus 1/10, which is equal to 9/10 or 90%. And 1 male. What was 1 male? Shh, thank you. 1 male was... this is where it gets a bit tricky. How many ways are there to get 1 male? We can look at it like this. To get 1 male, we could go a female and then a male. There was also a female and another male, so this is one way. This is another way. And then what was the other way? Couldn't we get just a male and then a female? And a male and a female and a male and a female? How many ways are there in which we can get just 1 male? There's 5 ways. Now, what we have to do is add their individual probabilities. So, let's do it here. To get 1 male, the probability of getting 1 male is equal to the individual probabilities added together. So we can go this way. We can go 2/5 times 1/4. Oh, no, we can't do that because that's a male. So that's 2 males. 2/5 times 1/4. Okay, now how many of those have we got? We've got 3 of them. So we can save ourselves a little bit of work. And then what have we got over here? We've got, what's this? We've got 1/4 times 3/5, and how many of them have we got? Good, 1/4 times 3/5, and then we've actually got 2 of those, and that is going to list the 5 ways. Now let's do a little bit of maths. We've got 2/5 times 1/4 is 2/20, 6/20 that's going to be, plus 3/20 times 2 is 6/20, which is equal to 12/20. And if we simplify that by dividing both sides by 4, that is going to give us 3/5 or 60%. That would be the hardest one to do, isn't it? The probability of 1 male, because you actually have to get these probabilities from the tree and factor in 5. Yeah. It is confusing.
Is that going to be like
Yeah, absolutely. Now, I'm going to after this question 3, I'm going to stop there and make a part 2 next class, and we're going to review over it. Okay? Now, a spinner is spun 50 times and the following results are recorded. Find the probability of the spinner landing on 2. Well, the number 2, we've got 5 events out of how many? 50. So 5 out of 50 is equal to 1/10. The number 5 is 11 out of 50. What would that be in a percentage? 22%. Okay? That's really good. Yep. No. Question will ask you. And if it doesn't, leave it in either way, either form, but preferably a fraction is fine. A simplified fraction. A number less than 4. A number less than 4 means that we're looking at 1, 2, 3. So therefore we've got 15, we've got 24 options out of 50. which is equal to 48%. An even number is 2, 4 or 6. There is 5 plus 7 plus 8 is 20 out of 50, which is equal to 40%. Are we okay with that so far? Now, we've got 3 minutes. Shh. I'm going to go through question 4 here, and we're going to just set up. Shh. We're going to set up a two-way table. Shh. Of 20 people, 12 have an interest in trains. So what we're going to do is we're going to say that T is trains, and then T complement is not trains. And it also says that we've got P is planes, and not P is not planes. Represent this information in a Venn diagram. Now, first of all, is there going to be some intersection? It appears so. So let's have this as T and this is P, and we're going to then make our Venn diagram, and there's going to be some intersection. Of 20 people, 12 have an interest in trains. That means that 12 is actually, this has to add to 12. 10 have an interest in planes, while 3 have an interest in both trains and planes. So therefore, this is going to be equal to 3. That's going to be equal to 3. And if 12 have an interest in trains, then that means that T not P is equal to 9. And then 10 in planes, which means that P not T, if you like, we can say that P intersection not T is equal to 7. Now, how do we do this in a two-way table? And this is why I'm going to show you that it's up to you. You do not need to do two-way table. Thanks, Matt. I'm getting really sick of people disrespecting me. I try to respect everyone in this class, but there are a number of students in here that are not respecting me. So I'll start showing less respect for you. Respect your other class members, please. The bell's going to go in 2 minutes. So we've got T and we've got not T. You do not need to do this. However, a question might ask you to do so.
Wait, sir.
Yeah.
Don't you need to add the 1 in the Venn diagram to add to 19?
That all adds to what?
It adds to 19, so don't you need to put 1 on the outside?
It adds to 20, doesn't it?
Yeah.
So this adds to, you're saying this adds, so that you're right. So there's one student, or there's one person that doesn't like trains or planes. Okay? Thank you. That's really good. So now what we can do is, thanks, Angeline, that was good. What we're going to do is we've got T and we've got not T. What we're going to do is we've got, this is actually the probability of T. And then we've got the probability of not T. Okay? Now, what do they have to add up to? T and not T have to add up to 1. And P and not P also have to add up to 1. So basically the probabilities, and this whole table here, has to add to 1. So now what we can do is we can actually all... Now we're not really dealing with probabilities here, we're dealing with numbers. Okay, so there's 20 people in the sample space. So let's have a look. T, what about where does T and P intersect? This 3 goes here. This is not P. What about where T, but not P? What's T that's not P? 9. 9, isn't it? Yeah. Okay. Now, therefore, 3 plus 9 is 12. And all of this has to add up to...
Would it be 20?
Yeah, has to add up to 20. What about this one here? What's in this column?
1.
1. Thank you very much. And that is there. And what is not T that's P? 7. And what do they all add up to?
20.
They add to 20. And their probabilities would add to? 1. Excellent. I'm going to stop the video there. Thank you for your attention from most of you. And I will see you tomorrow.